NASA wants to protect us from a planet-destroying catastrophe and has sent a robot to crash into an asteroid. But one thing about it is completely inexplicable and has left NASA researchers baffled. A statement says that something unknown is at work here. What is going on and why will this mystery decide the fate of our planet? Be sure to stay tuned until the end. Welcome, everyone. Have you seen the movie Armageddon with Bruce Willis? Feel free to let me know in the comments. For me, it's an absolute classic.
Even if from a scientific perspective, it might not be entirely accurate. But that's exactly what this video is for, because in reality, incredible things are also happening in asteroid research.
NASA is crashing a space probe into an asteroid and searching for elements on rocks in space that, according to the periodic table, shouldn't even exist. If you find exciting space missions like this as fascinating as I do, then why not subscribe to the channel? It costs nothing, you won't miss any more videos, and you'll be helping me enormously.
And for those who have subscribed, giving the video a thumbs up really helps a lot. Let's try to hit 5,000 likes. Thank you so much, everyone. Yes, in September 2022, NASA deliberately crashed a spacecraft into the asteroid Dimorphos. The DART mission was meant to prove that in an emergency, we could deflect a dangerous asteroid from its course. And in fact, the impact was a complete success.
Dimorphos was knocked out of its orbit, but what happened next was something no one had expected. But first things first, in September 2022, NASA did something that sounds like science fiction. It deliberately crashed a space probe into an asteroid. The DART mission was intended to prove that we humans are capable of changing the orbit of a celestial body. This is a capability that could one day save us from a catastrophic impact. The asteroid Dimorphos, about the size of the Pyramid of Cheops, was rammed by the DART probe on September 27, 2022. The mission was a complete success. The asteroid was indeed deflected from its original trajectory, but what happened next was something no one had anticipated. The Italian companion probe Ligacube, which had a front row seat to the whole spectacle, took images that have now been analyzed in detail and have amazed even NASA professionals. That's because researchers discovered something completely unexpected in these images. 104 massive chunks of rock that were hurled away from the asteroid like projectiles. Tony Farnham from the University of Maryland, the lead author of the new study, says, "We managed to deflect an asteroid to move it out of its orbit. Our research shows that the direct impact of the DART probe caused this change, but the ejected rocks provided an additional boost that was almost as large."
And here's where it gets really crazy. These ejected chunks were between 0.2 and 3.6 meters in size. Imagine a compact car hurtling through space at 190 kilometers per hour. But the shocking thing wasn't just their size and speed, but above all, their distribution in space.
We saw that the rocks weren't scattered randomly in space. Instead, they were clustered into two quite distinct groups, with material missing elsewhere, which means that something unknown is at work here. Farnham explains, these are words that cause every scientist both fear and excitement at the same time. When experts with decades of experience say they don't understand what happened, it usually gets exciting. The researchers have developed a theory about what might have happened. Presumably, the DART probe's protruding solar panels struck two large boulders on the asteroid shortly before the main impact. These boulders have even been given names, Atabake and Bodhran.
Sounds like two characters from a fantasy novel, but they're actually the culprits responsible for the chaos. Jessica Sunshine, one of the researchers involved and a professor of astronomy and geology, explains,
DART's solar panels probably hit two large boulders on the asteroid named Atabake and Bodhran. The evidence suggests that the southern cluster of ejected material is likely to consist of fragments of Atabake, a boulder with a radius of 3.3 meters. But why is this a problem? Quite simply, the ejected boulders gave the asteroid an extra push, and not in the direction the NASA probe was flying, but perpendicular to it. This means that Dimorphos was not only deflected, but could also start to tumble and rotate. Imagine this, I'm playing pool and I hit the cue ball. Normally you would expect it to roll in a certain direction, but in this cosmic game of pool, the balls fly in all directions. This may sound like a very theoretical scientific puzzle, but the implications are serious because this mission was a test run for the event that a dangerous asteroid really does hurtle toward Earth, and if we don't take all factors into account, our rescue missions could backfire. The comparison with another NASA mission is particularly exciting. Jessica Sunshine was involved in such a collision before during the Deep Impact mission where a probe crashed into a comet. and the difference couldn't be greater. Deep impact hit a surface that consisted mainly of very small uniform particles, so the ejected material was relatively smooth and continuous, she explains. And here we see that dart hit a surface that was rocky and full of large boulders, resulting in chaotic and filamentary structures in its ejection patterns.
This shows us that every celestial body reacts differently. Some are like a sandbox. When you hit it, the sand flies away evenly. Others are like a pile of gravel, where the stones fly around chaotically. And here comes the truly alarming part. The rocks that were hurled away generated more than 3 times as much momentum as the dart probe itself. It's like innocently ramming a nut into the ice, and suddenly an entire avalanche is triggered, carrying many times more energy.
This also means that the asteroid was not only deflected, but its orbit could be tilted to some degree. That may not sound like much, but in space, even the smallest changes can have a big impact. Dimorphos could now be tumbling through space like a battered boxer. The good news is that Dimorphos poses no threat to Earth. It is the small companion of the larger asteroid Didymos, and the entire system is flying past us at a safe distance. So we were able to test and learn without risk, but what does this mean for the future? We need to make our calculations more complex. If a killer asteroid really does come our way at some point and we only have one attempt to deflect it, we need to know exactly what will happen. Fortunately, help is on the way. This year, the European HERO mission will arrive at Dimorphos and investigate the effects of the collision on site. Then we will finally understand what really happened there. Tony Farnham sums up the significance perfectly. If an asteroid were hurtling towards us and we knew we had to move it by a certain amount to prevent it from hitting Earth, then all these subtleties become very, very important. This discovery shows us once again how much we still have to learn about our universe. Even in a seemingly simple collision between a probe and an asteroid, things happen that we cannot predict.
What if there are elements that don't even exist in the periodic table? Sounds like science fiction? Not for some researchers. They suspect that the asteroid Polyhymnia could contain a mysterious element with atomic number 164. If the theory is correct, we would discover matter that would turn our entire understanding of chemistry upside down.
To understand whether a new element has been discovered, we first need to look at what elements actually are. Elements are the most fundamental building blocks of matter. Each element consists of atoms that have a certain number of protons in their nucleus. This number of protons is called the atomic number and is characteristic of each element. For example, hydrogen has an atomic number of 1, helium has an atomic number of 2, and so on. But this immediately raises another question. What is the periodic table? The periodic table was developed in the 19th century by Dmitri Mendeleev. Mendeleev organized the elements known at the time into a table according to increasing atomic number and similar chemical properties. This resulted in elements with similar behavior being placed in the same columns or groups, and this grouping, in turn, made it possible to predict the properties of elements that had not yet been discovered at that time. The atomic numbers of these elements range from 1, hydrogen, to 118, oganesson. But why should 118 be the end? This is where a cosmic object comes into play, the asteroid Polyhymnia. It is part of the asteroid belt between the planets Mars and Jupiter. The asteroid belt is a kind of construction waste left over from the formation of the solar system. Billions of years ago, the inner planets were composed of dust and small stones, and the stuff that was left over is still flying around in the asteroid belt today. Polyhymnia is actually just one of many asteroids. A rock like any other if it weren't for one property, its density. Just like with people, everyone probably knows someone who doesn't really differ from the average, except that they're often especially dense.
You serious?
The density of Polyhymnia was calculated to be 75.3 grams per cubic centimeter, which is more than 3 times denser than the densest known element in the periodic table, namely osmium, with a density of 22.59 grams per cubic centimeter. How can this be explained? The density of an object obviously depends on the materials it contains. In the case of Polyhymnia, it is quite unlikely that the known elements from the periodic table alone could explain its extraordinarily high density. So the obvious explanation for Polyhymnia's density is that it contains materials that we have not yet synthesized in the lab or found in nature. In other words, elements that are not yet part of the periodic table. A research team from the University of Arizona has published a new paper on this and writes, "The mass density of this asteroid is thus far above the maximum density of known atomic matter. We therefore wanted to investigate whether these compact, ultra-dense objects could consist of superheavy elements beyond the periodic table." And now we benefit once again from the genius of the periodic table. Since we know how dense polyhymnia is, we can deduce where a suitable element would have to be located in the periodic table. The research team believes that there are hypothetical islands of stability in the periodic table where elements with higher atomic numbers could exist for longer. To explain the density of polyhymnia, they use the Thomas Fermi model of atomic structure to investigate the possible properties of elements beyond atomic number 118. For example, an element with atomic number 164 could be capable of explaining the extraordinary density of polyhymnia, provided it was stable enough not to decay immediately. The Thomas Fermi model specifies the radius of the positively charged atomic nuclei of a metal. In other words, the part of the atom that comprises the atomic nucleus and the electrons still firmly bound to it, and how densely the atoms are packed in a metal depends primarily on the radius of their nuclei. Researcher John Rafelsky, who was involved in the study, describes it as follows. We use the Thomas Fermi model because, despite its relative inaccuracy, it allows for a systematic exploration of atomic behavior as a function of proton number even beyond the known periodic table.
And the calculations showed that element 164 would have an atomic core radius between 0.13 and 0.16 nanometers, and that this would fit perfectly with the density of polyhymnia. But isn't that actually a bit like physics by wishful thinking?
There is extreme controversy among scientists as to whether such superheavy elements exist beyond the periodic table. In professional circles, this is also referred to as unobtainium. And as the name suggests, it has so far been considered impossible to produce these elements in the laboratory. I would therefore find it extremely exciting to send a probe to polyhymnia to bring a piece of this asteroid back to Earth.
Alright, mysterious elements aside, which asteroids are actually dangerous for us? NASA constantly monitors thousands of near-Earth asteroids and evaluates them using the Palermo scale. And believe me, there are some chunks out there that could really keep you up at night. Now I'll show you the top 3 most dangerous asteroids currently known to threaten Earth. Some of them could come closer to us than we'd like.
The Sentry monitoring system has been in use since 2002 and keeps a close eye on so-called Earth-crossing objects. Researchers look at the size of the objects, their speed, brightness, and a number of other factors. Incidentally, these are not just asteroids. Space debris can also be a near-Earth object, as can comets, of course. All these objects are recorded in the so-called Century Risk Table. And now, hold on tight, a whopping 1,451 near-Earth objects are listed on this table, including data on the impact risk. But don't worry, folks, that doesn't mean that all of these objects are actually heading for Earth and could destroy it.
Yeah, great. And when are you going to get to the promised scary moments? Right now, because NASA has identified asteroids that could actually be potential world destroyers. A bit like the Death Star from the Empire. Not as high-tech, but at least just as intimidating. Because just like the Death Star, these asteroids can destroy worlds.
Let's take a look at exactly which asteroids these are and whether they could really pose a threat to our planet. Incidentally, the Palermo scale is also important in this context. In Palermo in 1801, Italian astronomer Giuseppe Piazzi was the first to scientifically observe an asteroid. The value on this scale determines how dangerous an asteroid can be. Researchers calculate a value based on the impact risk, the potential for destruction, and the time remaining until a possible impact. Normally, this value is in the negative range, which is good for us because it means the impact risk remains low. In fact, there are hardly any asteroids that slip into the positive range, but some killer asteroids do make it there. Let's start with the third most dangerous one. This is asteroid 2000 SG344. This asteroid is 37 meters in size, twice as large as the asteroid that caused devastation in Chelyabinsk, Russia, just under 10 years ago. As a reminder, in 2013, the asteroid struck Russia, and its shockwave caused walls to collapse, windows to shatter, and nearly 1,500 people to be injured.
It would be similarly, or even more devastating, if this asteroid were to hit the Earth. On the Palermo scale, it has a value of -2.84, which makes a collision very unlikely. Nevertheless, researchers say that a possible impact could occur between the years 2069 and 2113. In this case, we can only hope that the asteroid lands in uninhabited areas or in the ocean. The impact energy released is estimated to be 1.0 megatons of TNT. The result would be an impact crater 30 meters wide. Here you can see the second-ranked object on the Palermo scale. This asteroid is called 100-1955 Bennu and is around 490 meters in size. Between 2175 and 2199, around 78 impacts could theoretically be possible. But the value on the Palermo scale is only minus 1.69, which corresponds to a probability of impact of 0.037%. Incidentally, the most likely date of impact is September 24th, 2182. So don't make any important plans for that day, folks, and now it gets really scary. Here you see one of the most dangerous world destroyers ever and the leader of the Palermo scale. We are talking about asteroid 290751950 DA. The name alone is kind of creepy. Let's just stick with 1950 DA. This asteroid crosses our Earth's orbit and is only a measly 2 kilometers in size. Despite its small size, researchers have deemed it so dangerous that it had a positive value on the Palermo scale for a long time. Its current value is minus 1.42, but that doesn't mean we don't have to worry. The probability of an impact is still 0.012%. Calculations of its trajectory show that the asteroid could strike the Atlantic Ocean. The probability of celestial objects simply striking water is of course particularly high, as 70% of the Earth's surface is covered by water. An asteroid of this size could not wipe out humanity, but it could still destroy entire continents through tsunamis and change the Earth's climatic conditions with unpredictable consequences. What exactly happens depends on various factors such as speed, angle of entry, and so on. The asteroids we discussed today are probably not large enough to destroy the Earth. For comparison, the asteroid that led to the extinction of the dinosaurs was probably between 10 and 15 kilometers in size, but they are still large enough that an impact could have devastating effects. Pressure waves, heat waves, clouding of the atmosphere by aerosols and a subsequent cooling of the Earth, acid rain, crop failures. An impact in the Atlantic would create a mega tsunami with waves around 100 meters high. But these asteroids do not have the same killer potential as other asteroids in Earth's history. And above all, we don't need to stress about it today, because even if the unlikely event of an impact were to occur, it would be far in the future.
And by the way, if you're wondering where the supposedly killer asteroid Apophis is on this list, scientists are now certain that it definitely won't hit Earth in the next 100 years, which is why it has been removed from the Palermo list.
I hope you now have an exciting insight into how important the exploration of asteroids and space rocks is for us.
Of course, I'll keep you updated on all the other exciting discoveries in space. So, if you haven't already, make sure to hit the subscribe button now, and with that, let's leave the asteroids behind us.
The Voyager probes have discovered something absolutely incredible at the edge of the solar system. A gigantic wall of fire surrounding our entire solar system. To learn all about this groundbreaking discovery, be sure to click on the video in the upper right corner. It's super exciting, and if you want the galactic Astro-Tim shirts from the videos, feel free to check out my space shop in the bottom left corner. Every order really supports my work, and there's some really exciting galactic stuff there. Otherwise, I'd say see you in the next video. Take care, folks.